So in this problem, we need to determine the coordinates of the vertex and the focus, equation of axis and directrix, and the length of the lattice rectum of the parabola given by this particular equation. Let us begin. So here we'll start with the given equation of the parabola. Here we have x squared plus y equals to 6x minus 14. What we're going to do here is rewrite the terms. We're going to transpose 6x to the left hand side and transpose y to the right hand side to get negative y minus 14. We will convert x squared minus 6x into a perfect square by completing the square. So we get x squared minus 2 times x times 3. We're going to add and subtract an extra term, so that's going to be 3 squared. That will be equals to negative y minus 14. So we have x minus 3 whole squared, negative 9 equals to negative y minus 14. X minus 3 whole squared will be equals to negative y minus 6 minus 5. Now what we'll do, we'll take negative as the common factor to get x minus 3 whole squared equals to negative times y plus 5. Now this is the equation of the parabola, although it is expressed in the standard form, but the vertex of the parabola has been shifted. So here what we'll do, we'll make two substitutions. We're going to substitute x minus 3 with x in uppercase and y plus 5 with y in uppercase, which means that equation 1 now is going to transform into x squared minus equals to minus y. Now this equation of the parabola can be compared with x squared equals to negative 4ay, meaning the value of a is going to be equals to 1 over 4. So let this be number 2. We're going to use this value. Now what we'll do, we'll start with this particular equation of the parabola. Now this is a downward facing parabola. So here we have the graph of x squared equals to negative 4ay. This is a downward facing parabola with its vertex at the origin 0, 0. The coordinates of the focus is going to be 0, negative a, and the line on which the focus and the vertex lie is going to be referred to as the axis of symmetry line. And since the axis of symmetry line is along the y-axis, so its equation is given by x equals to 0. And then we have the directrix passing through the point 0, a, and it is perpendicular to the axis of symmetry line. Its equation is given by y equals to positive a. And then we have the lattice rectum, which is the straight line passing through the focus of the parabola, and it is also perpendicular to the axis of symmetry with its endpoints on the parabola. So now we have this parabola expressed in terms of the new coordinate system x and y. According to this new coordinate system, the vertex of the parabola is at 0, 0. That means the value of x equals to 0 and the value of y equals to 0. However, we want to express it in the old coordinate system x and y. So what we'll do, we'll use this two equation, and in place of x, we're going to replace with x minus 3. X minus 3 will be equals to 0. And y plus 5 will be equals to 0. So solving for x and y, we're going to get 3, negative 5. So this is going to be the coordinates of the vertex of the parabola in the old coordinate system. Next, coming to the coordinates of the focus of the parabola in the new system. So that's given by 0, negative a. Here a is 1 over 4. So that means our coordinates will be 0, negative 1 over 4. So here x corresponds to 0 and we have y corresponding to negative 1 over 4. So here in the old coordinate system, we'll x equals to 0, but replace the value of x with x minus 3 equals to 0. So x will be equals to 3. And then we have y plus 5 equals to negative 1 over 4, which implies the y value will be equals to negative 21 over 4. So that means the coordinates of the focus in the old coordinate system will be 3, negative 21 over 4. Now coming to the equation of the axis of the parabola in the new coordinate system. So that's given by x equals to 0. So here in the old coordinate system, we'll replace the value of x with x minus 3 to get x equals to 3. So that's going to be the equation of the axis. Then coming to the equation of the directrix, So equation of the directrix in the new coordinate system is y equals to a. That means y equals to 1 over 4. But in the old coordinate system, the y has to be replaced with y plus 5. So we have y plus 5 equals to 1 over 4. And that's going to give us y equals to negative 19 over 4. So that's the equation of the directrix. And finally, we are going to compute the length of the lattice rectum. So length of the lattice rectum will be given by the absolute value of 4 times a. So since a value is 1 over 4, so this will be 1 unit. Now, this value is going to stay fixed because clearly here it is independent of the coordinate system, and also it talks about the shape of the parabola. So doesn't matter we are measuring in the new coordinate system or in the old coordinate system, the length of the lattice rectum will be always 1 unit. So we have successfully obtained the coordinates of the vertex of the parabola. So that's 3, negative 5. Coordinates of the new focus will be 3, negative 21 over 4. Equation of the axis is x equals to 3. Equation of the directrix is y equals to negative 19 over 4. And the length of the lattice rectum is 1 unit.